Hello, and welcome back. Our topic today, believe it or not, is area of a triangle. So we'll just start with a little geometry review again. Of course, back in geometry, all you knew how to deal with were right triangles. So I've given you a right triangle here, and hopefully you'll recall that the area formula for a triangle was 1/2 the base times the height. Okay, 1/2 base times height. And again, this is specifically for right triangles. So in this picture, I've got 1/2. The base here I call distance A. So I've got 1/2 A times the height, which I called H here. And let's just make a note here. Our height has to be perpendicular, which means that we create, a 90-degree angle. So this was the formula you've used up until this year. Area equals 1/2 base times height. Now, in trig, you've discovered, basically working with the law of sines and cosines, that you don't always have to have a right triangle. So what happens if you don't have a right triangle? How do you find its area? Well, let's go ahead and sketch this triangle in our notebook here. Triangle ABC. You'll notice it's not a right triangle. So I'm going to label this side A, of course, across from the angle, B across from this angle. And here's the formula we're going to use in trigonometry. It's 1/2 AB sine C. Now, the only trick is you have to have side angle side. Alright, so this has got to be starred, highlighted, grab a highlighter, grab a marker, do something. We've got to have 1/2 AB sine C, and you've got to use side angle side. And you can see how impressed this woman is here. A new formula for area of a triangle. 1/2 AB given side angle side. Alright, example 1. Simply put, find the area of this triangle. Well, all I'm saying is I can't use 1/2 base times height because I don't have a right triangle. So that's a great formula, but again, that was for right triangles. So now I'm going to use the trig formula. Area equals 1/2 AB sine C. Now, I just want to be very clear that just like in the law of sines or law of cosines, we can switch this formula. It could also read 1/2 BC sine A, or I could even say 1/2, which two letters here? AC sine B. Basically, the whole key is that these are your two sides, okay, and this is your included angle. So again, you have to have side angle side. So, back to this example. Notice I'm checking right away, side, angle, side, without skipping over anybody. So I can just jump to my formula. So I'm going to say this is 1/2, area equals 1/2, the two sides, so my two sides are 12 and 18, and then the sine of 94. And basically all of this is on one side of my area equation, so I'm going straight to the calculator and typing that in. And I get an area of 107.7 blah blah blah. And I'm just going to leave that for the time being. Okay, so the whole trick is that we have side angle side. Here's my side angle side in that order. And again, if this is all on one side of the equation and your A's over here, just type it all in on one line. Alright, let's dive into example 2. Given the parallelogram shown at the right, find its exact area. Okay, so two things to catch here. Notice they even put the word exact in capital letters. Remember from our previous trig days that exact means no calculator. Okay, so that means they're going to give us an angle that's 30, 60, 45, an angle we should know. So let's set up our problem anyway. The first question you have to ask yourself is, do you have side angle side? And I think you do. You've got your side, that angle right next to it, and the side right next to that. So our formula works. Area equals 1/2, the two sides, 10, 16, and then the sine of the included angle, sine of 60. Now, remember, this is exact value, so no calculator. So I've got 1/2, and I'm going to multiply these numbers together first. 10 times 16 is 160. And now the sine of 60 is something we should know. Think back to your table, close your eyes, picture your 30, 60, 45, sine of 60, hopefully you're saying is radical 3 over 2. All right, I'm going to keep multiplying. I know some of you find this hard to believe, but it's actually easier if every term's a fraction. So I'm going to put my 160 over 1. Okay, and I'm just going to multiply the tops together. So 1 times 160 times radical 3 is 160 radical 3 times the bottom, 2 times 1 times 2 is 4. Now, take note, this is the formula for area of a triangle. I want you to go back to this picture. How many triangles do you see here? A parallelogram is made up of 2 triangles. So I've got to take that answer I have, and I have to multiply it by 2. And again, it's easier if you make it a fraction, believe it or not. So I'm going to say 2 over 1. So I actually get an area of 320 radical 3 all over 4. And I can reduce this. 320 divided by 4 is 80 radical 3. Now, perhaps you might have thought a quicker way to get there. Let me just review this. We just said a parallelogram is made out of 2 triangles. And if the area of a triangle formula is 1/2 AB sine C, and a parallelogram is made up of 2 of them, you're really just taking this area that you have and multiplying it by 2. And what happens when you have 2 times 1/2? Well, they just cancel each other out. So let's make a note in our book. If you want the area of a parallelogram, it's basically the same area as a triangle, but just take out the 1/2. Area equals just AB sine C. All right, let's try another one. In triangle ABC, so we'll go ahead and sketch it out. Label your sides, or your angles. A to B equals 10. A to C equals 8. Measure of angle A is 45. Find the area of triangle ABC to the nearest tenth of a square unit. So again, every time you see area, you've just got to check for side, angle, side. Now these are starting off very nice, but eventually you won't have that, so it's going to take some work. So I've got side, angle, side. I'm good to go. 1/2, it's the 2 sides, the 2 lowercase letters, 10 times 8 times the sine of the included angle. Okay, so again, I know I just skipped the step with the letters, so let me just reiterate that. It's 1/2 AB sine C is the one I memorized. And in this case, I'm just going to label my sides here. I'm technically using 1/2 C times B times the sine of A. Okay? Or again, just keep saying to yourself the 2 sides and the included angle. Now, because it said nearest tenth, I'm going to go straight to my calculator and just type all of that in on the same line. And I get 28.3. And watch my units squared. All right, because I'm in area, I'm units squared. Number 4, in isosceles triangle. So let's just pause there. Remember that our word isosceles means 2 equal sides and 2 equal angles. So 2 equal sides, and they kind of, if you put those marks on there, they point to the equal angles. These are the 2 equal base angles. And the 2 equal sides measure 24, and they have an included angle of 30. So think about that, what that means. What angle is included between the 2 sides? Is this angle sitting included between the 2? I would say no. Neither would this one be. This angle up here is included right between the 2. And that's what that means. Now it says find the area of the isosceles triangle to the nearest square meter. So quick check. Do we have side, angle, side? Side, angle, side. Looks great. So I'm just going 1/2 AB sine C. So 1/2, the 2 sides. 24, 24, and then the sine of 30. Now, you could actually do this one without a calculator, and I'm going to take the time to do that. If it wanted the exact value, this would be a great example. I would have 1/2 times 24 over 1 times 24 over 1. And the sine of 30 we should know is 1/2. And again, when you have fractions, just multiply the top. So that gets me 576. All over, multiply the bottom, 4. And that's equal to 144. And my units were meters, and its area, so meters squared. And there we go. All right, so we're finally going to switch the question here. In triangle ABC, so we'll quickly label it, A to B is 12, A to C is 20. And this time they're telling you the area is 77. So let's make a note of that off to the side. Find the measure of angle A. So I'm going to put an X there in angle A. All right, so this requires a little bit of work. Again, you still need to check for side, angle, side. So I've got side, angle, side. I'm good to go. So 1/2. My two sides, this is side C and side B, so I'm going to say CB. Therefore, the sine of A is equal to the area. So I've got 1/2. My two sides are 20 and 12, and it doesn't matter the order you put them in. Sine of A equals 77. All right, so just take your time here. Let's talk about what's glued together. These guys are all stuck together, so I'm just going to take those numbers and multiply. Let's see, half of 20 is 10, times 12 is 120. Sine of A equals 77. Now, remember, that's glued together, so to get rid of the 120, I just have to divide both sides by 120. So we've got sine of A is equal, and this will get you some decimal. I've got 0.64166, blah, blah, blah. I'm going to store that in B. So I've got my sine of A equals B. And in order to solve for angle A, remember, I just have to take the inverse of both sides. So A equals, to the nearest degree, I get 40 degrees. And there you have it. Same type of question, just worded a little differently. All right, our next example is an old exam question, but I think it's very relative to many things in this world. So a farmer has a triangular field, like every farmer, whose two sides measure 450 yards and 320 yards. So let's go ahead and sketch that out. And it says the angle between these two measures 80 degrees. So the farmer wishes to use an insecticide that will cost $4.50 for every 100 square yards, or any part of 100 square yards. So basically, for every 100 yards I have in here, I have to pay $4.50 to cover it with insecticide so the bugs don't eat all the fruit or vegetables. What will it cost to insecticide this field? Well, if it's $4.50 per square yard, so I better jot that down, per 100 square yards, I should say, I probably need to figure out how many square yards do I have. And I think that's the question we need to find. How many square yards do I have? Then I can figure out how much it's going to cost me. So hopefully that word square to you, that should jump out at the page, and that should imply area. So let's grab our area formula. 1/2 AB sine C. Now, can you use the area formula the way it is? Well, do you have side, angle, side? I'd say so. So I've got 1/2. My two sides are 450, 320, and then the sine of 80. Quickly type that in your calculator, and I get 70,906.158. Blah, blah, blah. Now, let's go back to the question. It said it's going to cost me $4.50 for every 100 square yards. Well, this is how many square yards I have, so I basically just need to take that number and divide it by 100. Now don't round that number. We need an exact answer, so just take the number on your screen and hit divided by 100. I get 709.0615822, and again, don't round that number, because it said it's $4.50 for every 100 yards you have. Well, think about this. Do you have exactly 709 yards, or do you have 709 and a little more? I think you would agree you have 709 and a little more. So you have to round that up to 710 times the $4.50 gets you a total of $3,195. And that's how much it will cost to insecticide this plot of land. Samuel's decided to use stamped concrete for his backyard patio. He has chosen to make his design out of parallelograms, and he has designed the parallelogram pattern shown below. Find the area to the nearest tenth of a square foot. Okay, so again, square foot is implying area, and so is the word area. So I'm going to start with area equals 1/2 AB sine C. Now I just want to recall, that is the area for a triangle. And a parallelogram is made out of two triangles. So I'm basically just multiplying this by 2, which will kill the 1/2, because 2 times 1/2 is 1. So I'm really just using the formula AB sine C. Alright, now before we dive right in, just ask yourself, do you have the appropriate side angle side? And I would say definitely. Here's your side, the next angle, and the next side. So my area should just be 8 times 5 times the sine of 110. Hopefully you agree with that. We'll just quickly type that in our calculator. And I get an area of, to the nearest tenth, 37.6. And that is feet squared. Well, we've made it to the last question of the night. The art guild is painting a mural in the shape of an isosceles triangle. So let's go ahead and sketch that out. Remember that the word isosceles means 2 equal sides and 2 equal angles. So I'm going to stick my 2 equal sides, and I'm going to mark my 2 equal angles. Remember that those sides that you mark point to the equal angles. The equal sides of the triangle will each be 12. And the area will be 55. So again, they're giving you the area. Find the measure of the 3 angles of the triangle to the nearest hundredth of a degree. So not only does it want just one, it wants all 3 of them. Alright, now remember, you have to have side angle side in order to use the area formula. So if you have 12 and 12, who's the angle that would be between those two sides? Hopefully you're saying it's this upper vertex angle. So that would get me side, angle, side. So I'm going to go ahead and use my formula. Area equals 1/2 AB sine C. The area they told me was 55 equals 1/2. My two sides are 12 and 12. And I'm finding that upper vertex angle, sine C. Alright, so I'm going to type these numbers in together. So I've got 55 equals, half of 12 is 6, times 12 is 72, sine C. Divide both sides by 72. And I get 0.7638, blah, blah, blah. I get some nice ugly number, which of course I'm going to store. And I'm going to store that into alpha A at the time being. And if I want to find an angle, okay, we've done this a bunch of times now, you're taking the inverse. So sine inverse of A, and when I take the sine inverse, that just zaps the sine out over here. And I get an angle of 49.5 0.808, etc. And let me just quickly look back. It did say to the nearest hundredth. So I'm going to say that that upper vertex angle is 49.1081. All right, I'm just going to go back and label that in my picture. 49.81. Now, I don't have to do too much more work to get these missing angles down here. Remember, it wanted all the angles. And what's nice is that this is an isosceles triangle. So basically, I can just take my 180 and subtract my 49.81. And that leaves me with 130.19. Okay, so that's telling me that those two angles have to add up to that, but I also know they're the exact same because of the word isosceles, so I can just take that angle that I have and divide it by 2, which tells me that each of those base angles, and I'm running out of room here, should be 65 points 10 to the nearest hundredth. And there you have it. Well, that's all we have for area tonight, and we look forward to seeing you tomorrow.